In this video, we will take a look at factoring trinomials. And so the first type that we will see are those trinomials with the leading coefficient of 1. So now listen, remember trinomials have 3 terms, and none of those would be like terms. So they will take on the form, so ax squared plus bx plus c. Okay, so we notice we have an x to the power of 2, we have an x to the power of 1, and here we have an x to the power of 0 actually. So that's why you don't see the x in that term. And the first type that we will look at are where the leading coefficient is a 1. We won't write the 1, so it will just look like x squared. Okay? Now, so that's how you can identify when you can use this process. What I want you to recall from your multiplication of binomials, if we are multiplying x plus a times x plus b, what we get is equal to x squared plus a plus b x plus ab. And so when we are factoring trinomials, we're actually going from this stage back into the factored form where we have 2 brackets that are factors of the trinomial. So what we want to do is keep in mind that the coefficient of x is the sum of 2 numbers whose product is also the constant there. Okay? So we'll be asking ourselves to look for 2 numbers that have a sum of the coefficient of x and a product of the constant term. Okay? So let's just scroll down here and we will ask ourselves the same thing with this example. It takes on the same form. And so we're looking for, remember we want to break this 3 into the a plus b, right? So we want to have 2 numbers that have a sum of 3, and they also require to have a product of 2. Now, I can start thinking about numbers that have a sum of 3. All right, so sum of 3, let me do that in blue for a second. Sum of 3. All right, well that's 2 and 3, that's, 2 and 1. That's also 1 plus 2, or it's 0 plus 3, or it's negative 1 plus 4, or it's negative 2 plus 5, etc. Notice how this is probably going to go on and on and on forever, right? So the sum is not the best place to start in this case. So let's not start with the sum. We will start with the product because there will be a lot less of those, okay? So we want to find 2 numbers whose product is 2. Well, factors of plus 2, that is 2 and 1, because 2 times 1 is 2. And we have to remember the negative, so negative 2 and negative 1. Now let's see what those sum up to. If I do 2 plus 1, I get 3. And if I do negative 2 plus negative 1, I get negative 3. And the one that we need is actually the positive 3. So it's this one that will be the one that works out for us. So let's follow the same pattern. This is going to be x squared plus, now I'm going to use the a and b values from the formula, 1 and 2. All right, so let's do it bracketed first. 1 plus 2. I could write 2 plus 1 as well, it doesn't matter. And it's a plus 2 on the end. All right. That is just, let me scroll back for just a moment. I'm writing it in this form right here, x squared plus a plus bx plus ab. All right. You don't have to write that form every time. I just wanted to show you how it fits that pattern. So this will actually be equal to x squared plus, let's do the distribution, 1x plus 2x plus 2. So we have taken that term, 3x, all right, and remember it has to be equivalent to that, so it is. There's our 3x right there. So we're still equal to the original thing that we are trying to factor. We're just breaking up the middle term into two separate terms. And now we can take a look at, we're going to look at this part and factor that. And then we're going to look at this part and factor that. And I'll show you where we're headed with this. Let's take a look at the first two, x squared plus x. If I factor that, I get an x out, and I'm left with x plus 1. In my other one over here, I'm going to get a number and another, and I want it to also be x plus 1. Okay, so let's just double check. Factor the 2x plus 2, 2, and x plus 1. All right. Now this should happen. If it doesn't, something's wrong. But that's what we're aiming for, to have the same factors inside the brackets. And now this is actually the first bracket, because it's supposed to turn out like this, right? The second one I can say is x plus 1. The first one is the coefficients in front, which will be x plus 2. And if you want, you can try using FOIL to multiply those out, and that should be equal to x squared plus 3x plus 2. And now it's factored. And so let's try another one. Remember, I've got this table set up. I want to have the factors of -8, and we were looking at those in kind of red color. And I want to have them have a sum of -2. So now the higher the number gets here, the more factors that there will be. So let's just factor 8. Well, factors of -8. In order to have a -8, we must have one value positive and one value negative. So it's going to be 8 and -1, or -8 and 1, or let's see, 4 and -2, or -4 and 2. And that's it, right? Because that's all of them. So let's see what the sums of each of those are. 8 plus -1 is 7. -8 plus 1 is -7. So far it's not -2, so it's not working. Neither one of those is good. 4 plus -2, which is 2. And -4 plus 2, which is -2. Ooh, -2, -2. So there we go. Our A and B are -4 and 2. So let's write that out. X squared minus 4x plus 2x subtract 8. And I want you to see how this is equal. All we are doing that is different is this term right here, minus 2x, is being substituted right here, and that is minus 2x. Okay? That's the goal. Split it. Break it into 4 terms, and now we focus on the first 2 and the last 2 and do some factoring. factor the x squared minus 4x. Common factor is x, and it's x minus 4. I'll put a plus. Factor the 2x minus 8. Common factor is 2, and it's x minus 4. Remember, we want these to be the same, okay? If they're not, something, you might have the wrong sign here or something, okay? Just keep that in mind. Make sure they are the same. Now we have two brackets because we're aiming for this to be factored. And it doesn't matter what order they go in, but I've got here for the first one x plus 2, and the second one is x minus 4, or the other way around. Now this one in particular happens to be called a perfect square trinomial. We will see why it has that name after we get our answer. Can't always tell right from the start. After a while you might be able to recognize them, but right now it's hard to tell why it is a perfect square trinomial. Let's use the same process. Remember, we've got a coefficient 1, so we have this process where we are looking for two numbers, a and b, whose sum is what? Positive 12. And product is 36. Positive. Okay. So remember, it's best to start with the factors of the product. And I'm going to say that we have 6 and 6, or negative 6 and negative 6. I don't know why I don't have a larger table here, but let's do 9 and 4, or negative 9, negative 4, and so on. We could go down as far as we need to, okay? Let's first check on these ones. What sums do we have? 6 plus 6 is 12. And in fact, we found the one we're looking for right away. If not, we would continue with minus 6 plus minus 6, which is minus 12, and 9 plus 4, which is 13, and minus 9 plus minus 4, which is minus 13, and so on. But we happen to find it on the very first one. If not, you just have to continue factoring. Okay, so let's split this up. X squared plus 6x plus 6x plus 36. Factor the first two and then the last two. And we get x and x plus 6 plus 6x plus 6. Now this turns out to be x plus 6 times x plus 6, which is x plus 6 all squared, which is the reason why it is a perfect square trinomial when it is expanded out. Okay, so that's why. So that happens sometimes. All right, so you may be wondering, does this work when the leading coefficient is not equal to 1? Because the leading coefficient is not always 1. So we have another general trinomial that we can recall the factoring of. And notice that when factored, which is really where we're headed, that the coefficients of x at the beginning form the product of the coefficient of x squared. And so that's good to know. And then the constants b and d form as a product the constant at the end of the trinomial. And the middle term is AD plus BC. So we're going to use this fact again in a very similar process when we are factoring trinomials that don't have leading coefficient of 1. All right, so let's try this one. The leading coefficient is not 1, it's a 2. What we are going to do is multiply the leading coefficient by the constant at the end. And so 2 times 12 is 24. And we are looking for two numbers whose product is 24 and whose sum is 11. All right. We need a sum of 11. So let's see. We are going to do two numbers whose product is 24. There are going to be a lot of them. So we've got 24 and 1, 12 and 2. So I'm going to use up all my spaces. 24 and 1, 12 and 2. And for positive 24, there could be the negative of each of these, right? 8 and 3, 6 and 4, and the negative of all of those as well. Okay, so I'm just not going to show every single one, but that's what we would have to go through. Let's check the sums now. So 24 plus 1. We'll check the sum here is a 14. The sum of 8 and 3 is 11. Oops, there it is. And 6 and 4 is 10. So we have found the sum of 11 right there. And so in order to split this, 2x squared plus 8x plus 3x plus 12, we need to split the 11x into two separate terms of x, whose sum is 11 and whose coefficients have the product of 24. We'll go from there, and remember what we do, we kind of factor the first two and then the second two like that. So factor the 2x squared plus 8x, and I get a 2x, x plus 4, plus, and I'm going to factor the 3x plus 12, that will be 3, x plus 4. Remember, we want the same thing inside the brackets, and so this turns out to be 2x plus 3 and x plus 4 are the factors. And that's it. Thank you for watching.